Hello everybody, welcome to today's video. We are going to learn and discuss a few concepts in computer networks. So let's jump straight into it. So first of all, we ask ourselves, what is a computer network, right? We're going to simplify this a little bit further by asking, what is a network? And a good way to think about this is, a network is when you connect computers, printers, phones, and other devices together so they can share information. They connect by using cables or wireless signals. That's pretty much what a network is. Just different devices all talking and communicating with each other. So, here's what we're going to cover today. We're going to learn about different types of networks. Some are big, some are small. We're going to look at all the cables and equipments that make networks work. We'll discuss servers, which are kind of like storage rooms of a network. And we'll cover important security tools like firewalls, routers that keep everything safe and smoothly running. So, let's look at how a typical network is set up. You can see computers and printers connected to a switch, which is simply the box in the middle that connects everything together. The switch connects to a firewall, which is kind of like a security guard for your network. Then, the firewall connects to a router, which lets you reach the internet and other networks. Everything works together in layers to keep your data moving and secure. Okay, so we have three main types of network. They all come in different main sizes, and I'll explain each one bit by bit. So, first we have wide area networks, also commonly known as WANs. And these are the big ones. They cover large areas like entire cities or countries. The internet is actually the world's biggest WAN. These use phone lines or cable lines to send big data long distances. Next, we have local area networks, also known as LANs. These are much smaller, and these are where you find in offices or schools, just one building or a few buildings connected together. They use network cables and are much faster because everything is much closer together. And lastly, we have peer-to-peer networks. These are the smallest. They are just a few computers connected directly to each other. There's no special equipment needed, but they can't handle a lot of traffic. Okay, so let's go into a little bit more detail about WANs. These networks cover large geographical areas. Your data travels through phone lines or cable lines to reach faraway places. You usually need a modem, and that's the device to translate the signals. The best example would be the internet itself. It connects billions of devices all around the world, and that's pretty much a WAN in action. Next, we have local area networks. Now, LANs are different. These stay in one location, like your office building. Then computers connect with network cables, which makes them fast and reliable. Most LANs use something called the Ethernet, and you've probably seen Ethernet cables. They look like thick phone cords, and the Ethernet is a standard way to set up office and home networks. Next, we have peer-to-peer networks. Peer-to-peer networks is a simple setup. Just a few computers connected directly to each other. No singular computer is in charge, they're all equal. You don't need any special equipment like switches or hubs, you just connect them and go. But here's the catch. These networks slow down very quickly when you try to do too much. That's why they only work for very small setups, kind of like in a home office. Next, we're going to talk about fiber optic cables. These are the newest type of network cables. They're much better than old copper cables. Here's why. They send data much faster and they can carry more information at once. They don't get interference from other electronics, but the downside is they can be a lot more delicate and break a lot easier. But the speed advantage makes it much more useful for modern type of networks. Next, we have switches and hubs. Switches and hubs both connect devices together in a network, but switches are much better, and here's why. Switches are much faster because they send data directly where it needs to go. Hubs just blast the data to everyone, which wastes time. Switches are more secure. Your data only goes to the right computer, not to everyone on the network. That's why modern networks use switches instead of hubs. Next, we have servers. Servers are like the storage and service centers of your network. When you need something, you connect to a server. There are three main types: print servers keep track of all the printers and managing jobs; file servers store all the documents and all the files so everyone can access them; web servers host websites and web applications. Each type has a different specific job to do. Most importantly, we have IP addresses. Every device on the network needs an address. Think about it kind of like a house in a street. And for each device on a network, we call them IP addresses. IP stands for Internet Protocol. These addresses are made from four numbers separated by dots. There are two types. There's a static IP address, which never changes. Servers use these because people need to find them at the same address every time. Your web browser uses domain names, something like www.google.com, but behind the scenes, those translate to static IP addresses. Temporary IP addresses change every time you log in. Your home computer probably has one of these, and your internet provider assigns you a new one each time you connect. So, now you're probably looking at the word topology, and it's kind of simple. Topology is just a fancy word for the shape or layout of a network: how a device is arranged, how it connects. There are three basic types we use: star, ring, and bus. Each one has its advantage depending on what you need, and let's take a deeper look at each. So first we have star topology. In star topology, everything connects to a central point, usually a switch or a hub in the middle. Think of it like a wheel with spokes. All the computers are like at the outer edge of the wheel, and they connect to the hub in the center. When computers want to talk to each other, the data goes through the central hub. The big advantage is if one connection breaks, only that one computer is affected and everything keeps working fine. Next, we have ring topology, and it's exactly what it sounds like. All devices are arranged in a circle. Each computer connects to two computers next to it, forming an entire loop. Data travels around the ring in one direction until it reaches the right computer. It's like passing a note around in a circle of people until it gets to the right person. Next, we have bus topology. Bus topology uses one main cable that runs through the network. We call this the backbone. All the devices connect to one main cable. At each end, there's a terminator. That's a device that stops a signal from bouncing back. This was popular in older networks, but we don't use it as much anymore because newer designs work a lot better. Next, we have firewalls. Security is crucial. That's where firewalls come in. A firewall is a software that protects your network from threats. Think of it as a security checkpoint. Each piece of data that tries to enter your network gets checked against security rules. If something looks suspicious or comes from a blocked address, the firewall stops. This keeps viruses, hackers, and other bad actors out of your network. Next, we have routers. Routers are the traffic directors of the internet. They figure out the best path for your data to travel. And here's the key thing to understand. Routers connect different networks together. Your home router connects your home network to your internet provider's network. Then other routers keep passing your data along until it reaches its destination. Routers constantly check which paths are the fastest and which parts are slow. Then they send your data the fastest way possible. Next, we have wireless networks. Wireless networks changed everything. Now you can move your laptop around without unplugging cables. How does this work? Think of it like a walkie-talkie. Your computer has a wireless card that can send and receive radio signals. Your computer then converts its data into radio waves, sends them through the air, and the wireless router receives them. Then it works in the same way but in reverse. No cables needed, just radio signals traveling through the air. And finally, let's talk about the internet. The world's largest network connecting billions of devices. Here's something interesting. When you visit a website, there is no single fixed path your data takes. Instead, routers continuously figure out the best routes at that specific moment in time. If one path is slow or another path is broken, they automatically send your data a different way. That is why the internet is so reliable. There's thousands of possible paths your data can almost go through. And if one is given an issue, it can always take another path. So, let's recap what we learned today. Networks connect devices so they can share information. They come in different sizes: WANs for large areas, LANs for buildings, and peer-to-peer for small setups. We use cables, switches, and routers to move data around. Servers store information and provide services. IP addresses help devices find each other, and firewalls keep everything secure. These are the building blocks that make our connected world work. Thank you for watching the video. If you like it, please leave a like and comment at the bottom. Thank you.